Hi everyone, my name is Suram and I welcome you all to my YouTube channel. In today's videos we are going to discuss about the chapter Heat and Energy of Standard 9th. Heat and energy. So in this chapter we are going to discuss about the heat, energy, the difference between the heat and temperature, an anomalous expansion of water, and Hoppe's experiment. Then we have the greenhouse effect. Then we will see some natural consequences of anomalous expansion of water. Then we have the greenhouse effect and the global warming, and there are some effects of the global warming at the end. So let's start. Heat and energy. Heat and energy, standard 9th. So very first we are having heat. So heat, as you're knowing from the lower classes, heat is a form of energy that excites in us the sensation of hotness or coldness. These people might have seen, if we touch any hot body, then this can happen to our hands, is it? And if we are touching to the cold bodies, then our hands become like this, is it? So heat is a form of energy which causes in us the sensation of hotness or coldness, is it? So heat, hotness or coldness, is basically indicates that whether the heat energy is flowing in our body or whether it is going inside our body, is it? So the amount of heat energy present in a body is determined by the sum total of the kinetic energy and the potential energy of its molecules, is it? So on the basis of kinetic model of matter, we can say that the heat energy is the sum total of kinetic energy and potential energy of all the molecules of the given substance. Means how much kinetic energy and potential energy of all the molecules possess in a particular body, that sum total of its all kinetic and potential energy will give us the total heat of the body, is it? So this is about the heat energy. Then we have the units of heat. Unit of heat energy is same as the energy is having the unit, that is joule. As a unit of energy is joule, and CGS is erg. So joule and erg both are related to each other. So 1 joule is equal to 10 to the power 7 erg, that is here 1 joule is equal to 10 to the power 7 erg. Heat is also measured in calories also. 1 calorie can be defined as 1 calorie is the amount of heat required to raise the temperature of 1 gram of water to 1 degree Celsius. This is the definition of 1 calorie that you need to remember. Then we have the kilocalorie and kilocalorie, as you know, 1 kilo is 1000 gram. So then 1 kilocalorie can be equal to 1000 calorie. So we can say 1 calorie and joule both are related to each other, as 1 calorie is equal to 4.186 joule, or approximately it can be said that it is 4.2 joule, is it? 1 calorie is equal to 4.2 joule normally we are taking. So these are the units of heat. Then we have the next topic, that is the temperature. So temperature is what? Temperature is the degree of hotness or coldness. I mean how much hot is the body or how much cold is the body that we are measuring, and that measurement is known as, or that degree is known as the temperature. Temperature is measured in the different scales, you are knowing, degree Celsius, degree Fahrenheit, then Kelvin is another scale, is it? So temperature is what? It is a degree of hotness or coldness of a substance, that is called the temperature. So if a body is at higher temperature than its surrounding, it means the heat energy will flow out of the body, is it? Similarly, if the body is at lower temperature than its surrounding, then heat energy will flow into the body, is it? So on the basis of kinetic model of matter, we can say that temperature can be defined as the average of the kinetic energy of all the molecules of a substance. It is the average of kinetic energy of all the molecules. Heat energy was the sum total of all the kinetic and potential as well, is it? So here it is only average of kinetic energy of all the molecules of the substance, right? It is the kinetic energy only. So from here we can say that if the total kinetic energy of the molecules of a substance increases without any change of state, the average kinetic energy of the molecule will also increase, and hence the temperature will also rise, right? So we can say that the temperature is directly proportional to the average kinetic energy of its molecules, is it? So as long as the state of the body does not change, is it? So this is about the temperature. Next we have the difference between heat energy and temperature. What are the difference between heat and energy and temperature? Here is the difference. Heat energy is the sum total of all the kinetic energy and the potential energy that we have seen already in the definition, and temperature is the measure of which indicates the ability of a body to give out heat to another body or absorb heat from the another body. It is the sum of only kinetic energy. Is it? Total quantity of heat in two different bodies with different masses may be equal, but they may have the different temperatures. The flow of heat energy from one body to another body does not depend on heat energy. The flow of heat energy from one body to another body depends on its temperature. The amount of heat energy received by the cold body will always be equal to the amount of heat energy given by the hot body. The fall in temperature of the hot body may not be equal to the rise in temperature of the cold body. Is it? So these are some differences. And one more is that the temperature of the body will go on rising with the supply of heat energy as long as the state of the body remains unchanged. Means if you are supplying the heat to the body, then temperature of the body will remain continuously rise. Is it? Until there is a change in state of the body. Is it? So these are some differences about heat and temperature. The next we have the very important one, anomalous expansion of water. Is it? Anomalous expansion of water. Anomalous expansion of water is what? Generally all the liquids expands on heating and contracts on cooling. Is it? But water is one of the liquid which does not behave as same as normal liquids. Is it? It is showing the different behavior. Is it? Suppose if we have 1 kilogram water at 0 degrees Celsius and if we heat it, then the volume of water will decreases up to 4 degrees Celsius, right? And on increasing the temperature of the volume increases. When we increase the temperature, the volume of the water starts increasing, and the density of the water is maximum at 4 degrees Celsius. Here you can see from the graph it is clear. If you plot the graph between volume and temperature, the volume of water will decrease up to 4 degrees Celsius. Is it? If we take 1000 gram of water and if we start heating it, then with the rise in temperature its volume starts decreasing. That decreases up to 4 degrees Celsius here. Is it? And after 4 degrees Celsius, you can see here in the graph it starts increasing. Is it? Up to the different temperatures. Is it? So main temperature is between 0 to 4 degrees Celsius. Is it? So this different behavior means as we are heating the liquid, it should expand. Is it? But it is contracting here. Is it? The volume is decreasing. So this different behavior between 0 to 4 degrees Celsius is called the anomalous expansion of water. Is it? The expansion of water from 4 degrees Celsius to 0 degrees Celsius, right? Or contraction between 0 to 4 is known as anomalous expansion of water, means it is showing the different behavior as compared to the other liquids, is it? So here you can see, if we plot the graph between density and temperature, then the graph will come out to be like this. Means if we heat from 0 to 4, then 0 degrees Celsius, its density starts increasing and it goes to maximum 1, is it? 1 gram per centimeter cube at 4 degrees Celsius, is it? At 4 degrees Celsius, its density is 1 gram per centimeter cube, that is maximum, and then it starts decreasing, is it? Then it starts decreasing with the rise in temperature, is it? So this is, from this we can say that the water is having the minimum volume at 4 degrees Celsius and it has a maximum density at 4 degrees Celsius, is it? So it is clear from this graph, both the graphs also here. Maximum density at 4 degrees Celsius, is it? That is 1 gram per centimeter cube, and minimum volume at 4 degrees Celsius, is it? So this is about the anomalous expansion of water. Then we have Hope's experiment, that is to explain the anomalous expansion of water. Here we have the experimental setup for this Hope's experiment. We are having a circular cylinder and circular trough, we can say. Around this the cylinder, and around this there is a circular trough in which there is the freezing mixture. Freezing mixture means ice and salt. There is a mixture of ice and salt, and inside this there is a water, and it is having the two opening at the bottom and as well as at the top. So at the bottom there is one thermometer, and then at the top opening there is also one thermometer, T1 and T2, two thermometers are there, and in the middle there is a trough, right? So when the water's inside this cylinder, because of this freezing mixture, the water inside this start cooling, is it? So water which is below this freezing mixture, is it? The temperature of this water starts falling because of this freezing mixture, the temperature starts falling. Suppose this temperature, initially this temperature of this water is 10 degrees Celsius, is it? So because of this freezing mixture present, the water which is below this freezing mixture, it starts falling, and it starts becoming heavier and it moves downward, is it? And the warm water starts coming up. This process continues till the temperature of this water which is down the freezing mixture becomes 4 degrees Celsius, is it? So when it becomes 4 degrees Celsius, then at the same time the temperature of this thermometer T1 is recorded to be same, it remains same, is it? And temperature of T2 thermometer, it starts falling because the freezing mixture below, the water below the freezing mixture, its temperature is falling, is it? At the meantime the temperature of this T1 remain constant, is it? So when the temperature of this water which is below the freezing mixture becomes 4 degrees Celsius, then the water which is above this freezing mixture, it starts falling below 4 degrees Celsius. When it starts below 4 degrees Celsius, then the volume of this water starts increasing, is it? When the volume starts increasing, it means it starts cooling now below 4 degrees Celsius. So when the volume increases, the density of this water starts decreasing and it starts becoming lighter. So it starts moving up, is it? And here there is a layer of free ice starts forming here on the top, is it? As the temperature is falling below 4 degrees Celsius, so it starts becoming lighter, and here it becomes, there's a formation of ice, layer of ice on this upper surface, and the temperature recorded on this thermometer is 0 degrees Celsius. Is it? From 4 to 0 degrees Celsius. Is it? So it shows that the water is showing the different behavior, the anomalous expansion. This is due to the anomalous expansion. Is it? So we conclude from this experiment that is, at the lower temperature, at the lower thermometer, the temperature records 4 degrees Celsius. So we can safely conclude in this case that the density of water is maximum at 4 degrees Celsius, that we have seen already. And when the temperature falls below 4 degrees Celsius, the density of water decreases and it expands, that we have seen here, the water which is up here, up the freezing mixture, that we have seen in this case here. When the temperature falls below 4 degrees Celsius, the density of the water decreases and it expands and it starts forming the ice here on the top. So ice forms at 0 degrees Celsius is lighter than the water at 0 degrees Celsius and occupies more volume. So that is, it expands. So ice is formed at 0 degrees Celsius here. Is it? So freezing of water starts from top to the downward, but water in the lower region will stay at 4 degrees Celsius. So the water which is below this freezing mixture, it remains at 4 degrees Celsius. Is it? On the top the water get freeze. Here the water get freeze, but the below water remains at 4 degrees Celsius. Is it? So this is the Hope's experiment to explain the anomalous expansion of water. Then we have some natural consequences of anomalous expansion of water. Is it? Natural consequences, you might have seen in the cold countries, the lakes get freeze from the top. Is it? And the water downward, and all the marine creatures that are remaining inside the water, that remains safe. Is it? Because the top layer get freeze. Is it? And the summer or in the winter, you can see both the differences. The temperature of this water becomes more. Is it? But the lower there is, the water remains at 4 degrees Celsius. Is it? And in the cold countries here, the water on the upper layer, it is at 0 degrees Celsius. A layer of ice will form here. Is it? And the temperature of the lower surface water, that remains at 4 degrees Celsius, that we have seen in the case of Hope's experiment also. Is it? As the temperature of the water drops, it contracts. Is it? And its density increases and it sinks to the bottom of this lake, and this process continues till it becomes at 4 degrees Celsius, right? And as the temperature drops below 4 degrees Celsius, so on account of this anomalous expansion, it expands. Is it? So it expands and its density decreases, hence the upper layer of the water stays up only. So this continues till the water drops up to 4 degrees Celsius. So finally the change of state take place and it changes to form ice. Is it? So which floats on the upper surface of the water. Is it? So water in the lake does not freeze completely. So here in the lake, the water does not get freeze completely because the ice get formed on the top layer, so which is the wet conductor of heat also. It will not transfer, it will not allow the heat to go inside the water. Is it? So thus fish and other aquatic life get easily survive inside the frozen lake also. Is it? So as the water below remains at 4 degrees Celsius. Is it? So this is because of the anomalous expansion of water, right? So as the temperature of the water drops, it contracts and its density increases, and hence it sinks to the bottom of the lake or tank. It continues till the 4 degrees Celsius. So wherever has the temperature drops below 4 degrees Celsius, the water on account of its anomalous expansion expand and its density decreases, and hence the upper layer of the water stays up. So this continues till temperature drops to 0 degrees Celsius. Is it? So this is one of the natural consequences of anomalous expansion of water. Then we have some other practical consequences of anomalous expansion of water, like the bursting of water pipes, then we have the spoiling of our vegetables and fruits, then the frost bites. Is it? These are some natural consequences. So water pipes in the cold countries get burst because the water inside the pipes, is it, at sub-zero temperature it going to be expand, is it, because when water get freeze it will expand, is it. So because of the expansion it bursts the water pipe, is it. So people in the cold countries just keep their taps dripping at the night so as to provide the sufficient space for the expansion of freezing of water, is it. They will not tight the tap, they will not turn off the tap, they remain it dripping, is it. And as the ice water expands and it change the state into ice, and it exerts the tremendous pressure and which burst the steel pipes, is it. Next, vegetables and fruits and plants get damaged. That is because of the severe cold, because the water present in the plant cells on freezing expands, is it. Water in the cells of these plants expands on freezing, and which burst the and open the cells of the cell walls of the plants, is it, which get open and it destroyed the cells, plant cells you can say, is it. So plants get damaged. You might have seen in the winter season we are having the red signs on our fingers, is it. So that is called the first bite. So first bite is because of the same reason, because the water in the cells of the human beings get freeze, and in doing so it bursts the cells of our hands, is it. That is called the first bites, right. So these are some practical consequences of anomalous expansion of water. Then we have the most simple topic and important also, greenhouse effect and the global warming. Greenhouse effect. You people might have seen the greenhouse. What is the greenhouse? Greenhouse, you might have seen a plastic tent which is kept to which is used to grow up the plants, is it. And the nurseries you might have seen, they're growing up the plants there, is it. How the greenhouse work, is it. So that we'll see first. Greenhouse, is it. What is greenhouse actually? So greenhouse, in the greenhouse there is a heat energy is coming from the sun that is of smaller wavelength, is it. The heat energy which is coming from the sun, it is having the short wavelength, is it. So when it enters into the greenhouse, which is having the plastic tent you can say on it, is it. So when it enters inside it, the heat inside the whatever the objects are there, whatever the plants are there inside the greenhouse, it get absorbed by that, all the objects, whether it is plants or any other object, heat get absorbed, is it. So during the night when this heat radiation is emitted, that is of long wavelength, is it. So that long wavelength heat radiation is not allowed by the plastic tent to go out, is it. So because of that the temperature inside the greenhouse remains more, is it, as compared to the outside, because heat remains inside only, is it. Sometimes people might have seen in that inside the tent it becomes very hot. That is because of the same reason, because the sunlight which is coming from the sun, it is having the short wavelength when it enters into the tent, and when it is emitted back, that is of longer wavelength. So it is not allowed by the tent to go out, is it. So that is of longer wavelength, so heat remains inside the tent only. This is called the greenhouse, is it. This is because of the gases present in the atmosphere, is it, trapping the heat. It is trapping the heat and it is keeping that inside warm, is it. So that is called the greenhouse. So this is in, if we talk about the earth atmosphere is just behaving as a tent, is it. Earth is having the atmosphere around it, is it. A layer of atmosphere is there, and this atmosphere, you might be knowing, it is expanding up to 300 kilometer, is it? So when light is coming from the sun, that is, I have told you, it is of short wavelength. So on the earth surface there is a water, there is a different kinds of objects are there, water, plants, is it, houses, buildings, there are the different kinds of objects. So all that objects are absorbing the light, absorbing the sun heat. So during the night time, then when they radiate the heat back in the atmosphere, then that heat is of longer wavelength. So that heat is not allowed by the atmosphere to move back into the space. It remains inside the atmosphere only, is it? So because of that, our atmosphere, our earth surface remains warm, is it? And it is because of the greenhouse gases present in the atmosphere, which is absorbing, which is trapping this heat, like carbon dioxide and other gases, methane, is it? These are absorbing the these are absorbing the heat from the sun. These are called the greenhouse gases actually, is it? So this effect is called the warming of this earth surface. That is, this effect is called the greenhouse effect, is it? So the trapping of radiant heat of earth in its atmosphere because of its reflection from the carbon dioxide present in the atmosphere is called the greenhouse effect, is it? So this is the definition of greenhouse effect. And there is not only the carbon dioxide, there are some other gases also which is present, and these are causing the greenhouse effect. So because of this greenhouse effect, you might have seen the temperature of the earth surface is increasing day by day, is it? The temperature of the earth surface is increasing day by day. So this increase in temperature is known as the global warming, is it? So the term global warming is used to refer the increase in average temperature of air and sea at the earth surface. That's why we are using the global warming, is it? So scientists are more than, according to the scientists, there are 90% they are certain that most of the global warming is caused because of the increase in concentration of greenhouse gases, is it? Because day by day the greenhouse gases are increasing in the atmosphere. That is main cause of the global warming, is it? And that greenhouse gases are produced by the human activities, is it? So since the unequivocal and continuing rise in temperature of Earth's climate is called the global warming, is it? What is global warming? The unequivocal and continuing rise in temperature of the Earth's climate system is called the global warming, is it? So it is believed that the combined land and ocean temperature has increased at an average rate of 0.07 degrees Celsius, that is 0.13 degree Fahrenheit per decades. Per decade mean after 10 years since 1880, is it? Average rate is 0.07 degree Celsius. With this rate, after 10 years, the temperature of the earth surface is increasing by this degree Celsius, this much degree Celsius, is it? And it has been indicated that during the 21st century the global surface temperature is likely to rise a further 1.1 to 2.9 degrees Celsius, is it? So for their lowest emission scenario, and it is for 2.4 to 6.4 degrees Celsius for their highest emission scenario, is it? So it means the ranges of these estimate arise from the use of models with differing sensitivity, is it, to greenhouse concentration. So it has been observed that the earth absorbs short infrared radiation and other radiation coming out from the sun, and it get heated, is it? So the climate has changed, the earth's climate has changed day by day. That is because of this global warming, is it? Future climate changes and the associated impact will vary from region to region around the globe, is it? So effect of the increase in global temperature include a rise in sea level, is it, and the change in amount and the pattern of precipitation, is it, so as well as the probable expansion of subtropical deserts also. So warming is expected to be strongest in Arctic and the continuing retreat of the glaciers, is it, the permafrost and the sea ice. So the other worst effect of the warming includes heat waves, droughts, is it, and heavy rainfall, ocean acidification, then species extinction due to the shifting temperature reason, is it. So further threat of the food security from the crop yield and loss of habitat from inundation are also after the effect of warming, is it. So there are the different effects of this global warming, and it is dangerous for the earth surface if we stop, if we are continuing with this rate, then it is very difficult to survive on the earth surface. It will be going to very difficult to survive on the earth surface if we are not stopping the production of the greenhouse gases, is it. So there are some effects of this global warming that we'll discuss at the end. What are the effects of the global warming? So due to the increase in temperature, snow and ice near the poles will start melting fast. So this will give rise to the level of sea and river, which may cause the damaging effect, is it. So because of the melting of ice, the level of the sea water and the ocean water will increase, is it, so which will cause the less land to survive, is it. So due to rise in sea level after melting of ice at poles and glaciers, the coastal areas will be badly affected, causing great loss, is it. Then we have, it will then affect the product of cereals and other agricultural products and crops, is it. So because the less land will left for the cultivation, is it, so it will have the damaging effect again. So it will change the climate conditions, which can cause the floods, the droughts, is it. So these are some damaging effects of the global warming, is it. So we should try to stop the production of greenhouse gases, is it. That is the only way to avoid the global warming. So to minimize the global warming due to the greenhouse gases, we should have the forestation, and we minimize the use of fossil fuels, is it. We should plant at least one tree, is it. Everyone should plant at least one tree, that we encourage the forestation, and we should minimize the use of fossil fuels, is it. That is only the way to reduce the global warming. So this was all about this chapter. Thank you.